this is called a public goods game. Okay, and so here's how it's played. At the beginning of the experiment, each player is given $1. Then they're asked to make a decision. Contribute your dollar to the public fund or not. After both players have made their decision, any money in the public fund is multiplied by 1.5. And then the game ends. Players get to keep their dollar if they kept it. And any money in the public fund is divided equally between the two players. Let's write down the payoff matrix if you understood the game. So we have player 1 and player 2. And both of them can either contribute or not. I'm just going to write C and DC for contribute or don't contribute. Okay, let's start in the bottom right corner. Neither player contributes. What's their payoff? They each get 1, right? So here we have an outcome of 1-1. Let's now go to the top left. Let's say each contributes. How much do they each get? So what happens is follows. Player 1 contributes $1 to the public fund. Player 2 contributes $1 to the public fund. So there's $2 in the public fund. The amount in the public fund is multiplied by 1.5. So that $2 becomes $3. Then that $3 is divided equally to the players. So each player gets $1.50. Now that we understand how the game is played, see if you can fill in the off diagonals. If we're in the top right, player 1 contributes $1 to the public fund. That is multiplied by 1.5, so that becomes $1.50. That $1.50 is divided equally to the players. So player 1 gets 75 cents, but how much does player 2 walk away with? $1.75, because he kept his dollar, right? He did not contribute. He kept his dollar, and he gets 75 cents in the public fund, so he gets $1.75. And the exact same thing happens in reverse down here. Player 1 doesn't contribute, player 1 does. The public fund rises from $1 to $1.50. That's divided equally, 75 cents each. And then player 1 gets $1.75, and player 2 gets 75 cents. So this is another example of game theory. Has nothing to do with oligopoly or prisoner's dilemma, right? But you're starting to see why this model can be used to illustrate many types of situations. Does either player have a dominant strategy here? Well, let's first ask ourselves whether player 1 has a dominant strategy. If player 2 contributes, what should player 1 do? So we know that we're going to be in one of these two cells. If player 1 contributes, he gets $1.50. If player 1 contributes, he gets $1.50. If player 1 does not contribute, he gets $1.75. So what should player 1 do if player 2 is going to contribute? Don't contribute. $1.75 is bigger than $1.50. So if player 2 contributes, player 1 should not contribute. What if instead player 2 does not contribute? What should player 1 do? Not contribute. If player 2 does not contribute, we're over here in one of these two cells. And so if player 1 contributes, he gets 75. If he does not contribute, he gets $1. $1 is bigger than 75, so player 1 should not contribute. In other words, no matter what player 2 does, player 1 should not contribute. And the same thing is true for player 2. What should player 2 do if player 1 contributes? Not contribute. Why? Because $1.75 is bigger than $1.50. And if player 1 does not contribute, what should player 2 do? Again, not contribute. Now because $1 is bigger than 75 cents. So the dominant strategy for each player is to not contribute. That means both players playing their dominant strategy will lead to a situation where each player gets $1 in payoffs. But notice, both players would be better off if both could contribute. And so this is an illustration of the free rider problem. We're not going to get public goods provided individually or voluntarily by individuals. And so we talked about the free rider problem earlier with respect to providing public goods. This is a situation of market failure. And one justification for government intervention is to overcome the free rider problem. To tax people, to make them put their dollar in the public fund, basically. And it turns out that everyone will be better off, right? Because everybody will get higher payoffs than if we don't.